Okay, we want to look at these problems where we have to convert one metric unit to another. This involves using our metric prefixes and conversion factors that we talked about in class. If we look at example 1, we have 4.5 picometers and we want to know how many micro, that funny looking, what you might call M, is a mu. So our procedure would be to go from picometer to meter, from meter to micrometer. Now, in order to do this, we need to establish our conversion factors. And our conversion factors come from the metric conversions, our metric prefixes that you will have to learn for the exam. You will not be given those. And here is a list of some common ones. So the conversion factors go as follows. As I stated in class, 1 will always go with your metric prefix. The metric prefix is pico. The exponential goes on the other side of the equal sign. Pico means 10 to the minus 12. So 1 picometer is 10 to the minus 12 meters. And that's the first conversion. The second conversion, we want the relationship between meters and micrometers. So in 1 micrometer, we have 10 to the minus 6 meters. So you can see that over here. That's how we establish those two conversion factors, by knowing our metric prefixes. So I also stated in class, I'm not going to go through this for all of them, but the fact that this equality is true makes 1 picometer divided by 12, divided by 10 to the minus 12 meters and 10 to the minus 12 meters over 1 picometer. The fact that this equality is true means that this is true and this is true. These two ratios are actually equal to 1. Now, let's solve this problem. So 4.5 picometers times, the first step is we want to go from picometers to meters. So in 1 picometer, we have 10 to the minus 12 meters. So the units of picometers cancel. The next step is we want to go from meters to micrometers. So in 1 micrometer, we have 10 to the minus 6 meters. Now, we need to multiply and divide all of these things out. So we have the 4.5 from here. We have the 10 to the minus 12 from here, and the 10 to the minus 6 in the denominator from there. So we will have 4.5 times 10 to the minus 12 This minus 12 is already in the numerator. Now, our laws of exponents say if I want to bring this to the numerator, which is what I like to do, I have to change the sign of my exponent. So instead of 1 over 10 to the minus 6, that becomes 10 to the 6. It's the same thing as subtracting exponents. Some students say, well, I can have 10 to the minus 12 minus a minus 6. This is the minus 6. So that becomes plus positive, and that would be 10 to the minus 6, which is exactly what we will get here when we add the bases. We'll wind up with 4.5 times 10 to the minus 6 in the unit of micrometers. Now, you have to go through and practice those steps so that you make sure you don't make any careless errors when you're doing these problems. You don't put the exponential with the metric prefix, that it actually goes on the other side. The number 1 goes with the metric prefix. Now, let's look at the second example. Now, the second example involves a unit that already has an exponential, and you should not be confused by that. So we have 5.75 times 10 to the third nanograms, and that's equal to how many gigagrams? So we're going to go from nanograms to grams, our base unit of grams, to gigagrams. So we will need, indeed, 2 different conversion factors: a relationship between nanograms and grams, and a relationship between gigagrams and grams. So our conversion factors: in 1 nanogram, we have 10 to the minus 9 grams. In 1 gigagram, we have 10 to the 9th grams. That's this metric prefix and that metric prefix. So we can work this out using those 2. So we write out 5.75 times 10 to the third nanograms times, in 1 nanogram, we have 10 to the minus 9 grams. Unit of nanogram cancels. In 1 gigagram, which is the unit that we're trying to obtain, we have 10 to the 9th grams. Unit of grams cancel. So let's complete this problem by doing the multiplication and or what you may call division. We have 5.75 times 10 to the third, that is that expression, times 10 to the minus 9, that comes from here. Now, as I've stated, I like to move my exponent of 10 from the denominator to the numerator. So since this is 10 to the 9th in the denominator, I need to make that 10 to the minus 9 when I bring that to the numerator. And that is the same thing as subtracting exponents. Adding a 3 plus a minus 9 and subtracting a minus 9 would give me the same thing. And what I mean by that, that would be 10 to the third minus 9 minus 9. This minus 9 came from here, which is the exact same thing we're doing here. So the answer to that problem would be 5.75 times, I have a base of 10, 10, and 10. So minus 9 plus minus 9 is minus 18 plus a positive 3 would give us a minus 15. So 5.75 times 10 to the minus 15. And our unit is gigagrams. And that will be our final answer, and this is in scientific notation. Now let's look at the third problem. Our third problem goes from kilometers to picometers. So we want to go from the unit of kilometer to picometer. So in order to do that, we must go from kilometer to meter, and from meter to picometer. So this is a two-step conversion, and we will need two conversion factors. What are our conversion factors? What two do we need? And 1 kilometer is equal to 10 to the third meters. One going with my metric prefix of kilo. And 1 picometer is equal to 10 to the minus 12 meters. Again, one going always with the metric prefix. So we can set that problem up and say 775 kilometers times, we know we want to eliminate kilometer and go to meter. So our conversion factor is, in 1 kilometer, we have 10 to the third meter. Kilometers cancel. Our next step is, we know we want to go from meter to picometer. So we want picometer in the numerator, and we want to eliminate meter in the denominator. So in 1 picometer, we have 10 to the minus 12 meter. Unit of meters cancel. So what we wind up with is 775 times 10 to the third times my 10 to the minus 12 is in the denominator. I want to bring it to the numerator, and that becomes 10 to the 12th. Now, I can add like bases, and that's going to equal, come down here, 775 times 10 to the 15th picometers. Now, this number is not in scientific notation, whereas scientific notation, this number must be between 1 and 10 multiplied by 10 raised to some power. So what I can do is move the decimal point 2 places to the left. That would give me 7.75 times 10 to the 15th. For every place to the left I move the decimal, I must increase a power of 10. So that would give me 10 to the first times 10 to the first, or 10 squared. And our final answer would be 7.75 times 10, add the power of 15 to the power of 2, gives us 10 to the 17th, and the unit of picometer. Okay, now the last problem starts with 50,000 micrograms. And we're going to go from micrograms to nanograms. So let's go ahead and say we're going to go from the unit of microgram to gram, from gram to nanogram. So we know that we need a relationship or a conversion factor between those two, and a conversion factor between those two. So let's write that out in one microgram, we have 10 to the minus 3 grams. In 1 nanogram, we have 10 to the minus 9 grams. Now, let's set up our problem. So we have 50,000 micrograms. In 1 microgram, strictly from our conversion factors here, we have 10 to the minus 3 grams. So the unit of micrograms cancel. Now, I know I want to achieve the unit of nanogram, and I want to eliminate the unit of gram. So, strictly from our conversion factors here, in 1 nanogram, I have 10 to the minus 9 grams. Now, I'm going to write this below. We would have 50,000 times 10 to the minus 3. Now, bringing this exponent of 10 to the numerator becomes 10 to the 9th. So I can say that's 50,000 times 10 to the add exponents, and that becomes 10 to the 6th. And the same thing would happen. You would get this 10 to the 6th if you did 10 to the minus 3 minus a minus 9, which becomes negative 3 plus 9, which gives you 10 to the 6th. Either way you choose to do it, you will arrive at the same answer. Now, notice that this number is not in scientific notation. This number is not in scientific notation because 50,000 is not between 1 and 10. So I need to move this decimal 1, 2, 3, 4. So that would be 5.1234, just keeping those zeros. I moved the decimal place 4 places to the left. So that becomes 10 to the 4th, or for each place you could say 10 to the 1st, 10 to the 1st, 10 to the 1st, 10 to the 1st, which gives you 10 to the 4th. And my answer in scientific notation would be 5.0000 times 10 to the 10th with the unit of nanograms. Okay, if you have a problem with these conversion factors, try to rework them without looking at the answers. And if you're still uncertain, bring any problems you may have to class and the study sessions.